Welcome to The Explainer. Today, we're diving into something that feels a bit like chemical magic. We're talking about a color that isn't made in some big vat. Nope, it's actually created inside the very fabric it's supposed to dye.
So you're probably wondering, how on earth is that possible? I mean, we're not just talking about dipping fabric in some color that's already made. This is a whole different ballgame. It's a process where the dye itself is literally born, fully formed, deep down inside the fibers of the cloth.
You know, this stuff is so fascinating, it has a bunch of different names. And what's cool is that each name kind of gives us a little clue about the secret behind how it's made. Okay, so for example, it's called ice color. Pretty straightforward, right? That's because the whole chemical reaction needs to be super cold to actually work. Then you've got magic color, and that name comes from its insane versatility. You just tweak the ingredients a tiny bit, and bam, a whole rainbow of different shades can just appear, seemingly out of thin air. But okay, let's pull back the curtain. The secret, of course, isn't actually magic, it's just really cool chemistry. So, an azoic dye, it's not a color you just slap onto a fabric. Instead, you've got these two separate, totally colorless parts that react with each other and build a brand new colored molecule, right there inside the fibers. So, let's get into the nitty-gritty. How does this chemical magic trick actually work? Well, it all comes down to two key ingredients. And the weird thing is, on their own, they're completely unremarkable and colorless. Okay, the best way to think about this is like a two-part epoxy glue. You know the stuff? When they're separate, they're just these two different liquids, kind of useless. But the moment you mix them, they have this chemical reaction and form something super strong, totally permanent, and, in our case, brilliantly colored. All right, so the real genius here isn't just the ingredients, it's how we get them to combine right there on the fabric. It's this really precise three-step process that basically sets the stage for that final awesome color reveal. So here's how it goes. First, we get the fabric ready by soaking it in naphthol. Think of this as loading one half of our recipe right into the material itself. Then, completely separately, in a bath that's gotta be ice cold, we get the second component ready. And then, for the grand finale, we bring the two together. And that's the moment the magic happens. And this is it. This is that final moment. The fabric, which is already carrying that naphthol molecule, gets dipped into the diazo solution, and instantly, the two components meet, they couple, and boom, a brand new colored molecule, the azoic dye, is born, right then and there, locked tight inside the fiber. Now, let's talk about that temperature again, because it is absolutely critical. Seriously, it's not just a suggestion. You have to keep that diazo solution that cold for it to be stable. If it warms up even a little bit, the reaction just won't work. Game over. And that's exactly why they call it ice color. Okay, so what do you get out of all this? I mean, this whole in-fabric creation process is pretty unique. Well, it turns out you get a dye with some really distinct and, frankly, very desirable properties. Here's the thing. Because that final color molecule is literally built inside the fiber, and because it's completely insoluble in water, it's physically trapped. There's nowhere for it to go. It just can't be washed out. And that's what gives azoic dyes such amazing wash fastness. The colors just stay bright and true wash after wash after wash. All right, to really nail down what makes this whole process so special, let's do a quick comparison. Let's put azoic dyes side by side with their much more common cousins, the standard azo dyes. The biggest difference, the real game changer, is right there in that first row. A normal azo dye is just a ready-made color. You dissolve it, you apply it, you're done. But an azoic dye, it isn't even a dye at all until it's created during that complex two-bath process. We're talking about a fundamentally different way of thinking about how to create color. And this quote here really just nails it, doesn't it? It perfectly sums up the big idea. The color isn't just slapped on top or painted on. It is literally developed right there on the material, becoming a true integral part of the fabric. You know, when you get right down to it, this whole process is just such a great reminder. It shows us that so much of what looks like magic is really just a clever, totally fascinating bit of science hiding in plain sight, woven right into the clothes we wear every day.